So we are talking about, so there was, I was talking to Masoud on what the topics are. There's so much to talk about in terms of research, innovation. So I picked my favorite, which is around data. So I picked that because my role in Spark is I lead the data initiatives in Spark. So I have data engineering, data science, and also what we call as realizing value for data. So those functions who are building use cases in Spark to deliver value. And I also have another part, which is the automation part, which is around developing automation solution, not the industrial ones, but the ones on robotic process automation, as well as using machine learning for automation. Now, it was an engineering faculty building, so I thought people will be interested in engineering, so I will start with that, is that the basis of innovation on data is probably not in the data itself, because data existed for a long, long time, and AI models were there in 1950s or 60s. But what made the difference was the computational and the compression capability, which came with Moore's law, and I don't probably need to describe Moore's law to most of you, but it was around doubling the capacity of transistors in 18 to 24 months. For a business like us, which is telecom, there is another law, which is called the Cooper's law. And what the Cooper's law says is that given a radio spectrum, the amount of data or voice transaction which will go through it doubles in 30 months. So in 2.5 years, we have one more generation of telecom capability which comes in. And these are generally given Gs, like 2G, 3G, 4G, and now it's 5G. But I guess, as you see, the amount of data is increasing rapidly. And on the right-hand side, that's not the picture of an ET, but that's the picture of the quantum computing model. That's the Google one. There are quite a few in the market. But I guess the potential of that is it will continue to have the computing capability to fulfill the vision of digital and data transformation. And to do that, there is another thing to look at, which is as the computer power increases, so does data. And we engaged with Bell Labs, and they were engaged to do a study with Spark to describe the potential of data, especially because we have to carry so much data through our networks, being Spark, which is a telecom company. And as you can see, that there are points of inflection: browser, search, personal content, Napster. Probably quite a few weren't born when Napster was there in this room, but it's a different discussion. Netflix, YouTube, the video world. And now we are in the sharing world of Amazons and Airbnbs. But the interesting part is the graph below, is the amount of data and the explosion of data which is happening. The ZB stands for zettabytes. And a zettabyte is a million terabyte, a billion terabyte to be precise. I got the zeros wrong. So that's the scale, and that's the amount of data that is coming into the system for us to process. So that's why we need a solution to transport that amount of data. And we had 4G. Now what we are looking at is 5G, which is the potential is that it will be around a lot faster than 4G and with low latency. So what does that mean in terms of use of that capability? So if we have a lot of data, we can transport it fast. So what does it give? Autonomous vehicles. All the school ads we see about vehicles running on their own, Teslas and other companies of the world. The management of that needs an telecom interface which can respond to that amount of data being transferred on the go. So that's the autonomous vehicle use case. Then cloud gaming. How about we start our gaming journey at home and walk into a transport and nothing changes. So that's the amount of power of the interface of the network which is needed to give some of this experience to life. So the way it is structured is, on the top are the ones which require a high latency and reliability. On the right are the speed and capacity ones. Middle is the IoT, and that's probably a whole new area of devices interacting, using the connections and the data enabling those use cases. An important use case is drone and connected robots and how they connect with each other in an integrated way. 5G is one of the enablers of that. Then there is edge computing. There are use cases which are coming up in telehealth. For example, how do you engage in a telehealth capability where you have images which needs to be transported over the network so that the telehealth recommendations can be done. So there are various facets of 5G, but this will also create some use cases, which one of them is America's Cup. So on right-hand side, what you see is what would be a normal experience in an America's Cup, where the Emirates team, New Zealand, will have a boat which will go with the main boat and try to gather data so that they can redesign or change the boat to make it go faster. But that's a very laborious process. Because you have to run with the boat, gather the data, then go back to shore, download it, analyze it, and make changes. What on the left-hand side is essentially the capability of using 5G, get the live data stream, and why you need 5G is the amount of data is really high. Get the live data stream, process it, analyze it, and then make changes to the design. What it saves is the most precious commodity in the race. That is time. So you save the time to get ahead. So if we have, that was a use case of 5G using data. Now there are other use cases. Spark is very keen on two other sectors. One is health, and another is IoT. Now, on the left-hand side, what I was looking at over the week, especially with all the situation over the world around COVID, is health and how some people are getting affected by COVID and some aren't. So there is probably some factor in our genes. And what if we have precision medicines for everyone in the planet to direct the medicines which will work for them? Now, that's a great concept. A human genome costed $10 million to map in 2007. Right now, the cost of mapping a human genome, because of the advances of Moore's law, is less than $1,000. And in some cases, especially for those cases where they are used for commercial purposes, for example, identifying some linkage with the genome sequence. So the potential of precision medicine is increasing. There are various safeguards around privacy on actual use of this capability to target medicine. There is a lot of work to be done, but there is a whole lot of potential on using the computational power to enhance our lives. On the right side is a case of agriculture, and the case of agriculture is with IoT. The devices can help to optimize the most crucial resource in the agricultural food chain, which is around nutrients, water, supply. Things which are impacting the environment can essentially be optimized for maximizing productivity. So this comes to the higher problem of the world hunger problem. because the population of the world is increasing. The cultivated area is probably same, and if you increase it, that has an environmental impact. So there has to be a solution which creates a capability to optimize and make more precise judgments in what we do with agriculture. Both are sort of areas, IoT as well as health, where Spark is interested in. I'll describe what some of our journey is. But the third one is the people who are really made it big in terms of using precision machines to deliver value are Google and Amazons of the world. Their whole business model is based on it. And they got the data, they built great customer experiences, more people got on it, they got more data, and they got better. So this flywheel effect was like a virtuous cycle of better experiences, cost-effective solutions, as well as then that gets more data, and they keep on going better. So how does that relate to a company like Spark? Because we are not a Google, we are not an Amazon, we are not that big. And we are in the cycle of innovation through data, because unless we innovate, staying still isn't an option in this world anymore, because the world is changing so fast, you need to go with it. So this is what Spark has decided to do. So in the middle are 3-4 major bets Spark is picking for developing or investing in for a 3-year cycle. So we have a 3-year cycle started last year. We are in the mid-year, and the 3-4 major key capabilities are: one is automated smart network, which is the 5G capability, which we discussed some use cases. On top is a simple, intuitive customer experience. So how do you make the customer experience more intuitive and simple? But both are based on the fact that we have the data beneath it to understand the customers and also offer the right experiences, and also manage our networks in a way that it gives the right experience, and we invest in the right parts of the network. Now, what it enables is our established businesses like wireless, broadband, cloud, but on the right side, it enables those IoT use cases of agriculture, it enables digital health, and also sports. I guess some of you or most of you know about Spark Sports, and that data set beneath these capabilities enable those use cases to be delivered. So ultimately, the idea is that someday we will have the data which gives us competitive advantage and also enables to give us automation for the customer experiences, makes us to work, develop more capability network, and gives great insights for our customer. Now, this may be interesting for you, is that the R&D spend provides great returns. So if you see the business case of putting money in innovation on R&D, and there is a report on who were the biggest spenders in 2018. They were Amazon, Alphabet is essentially Google, Samsung, and Microsoft. And you know how the story panned out in 2021. We may not be able to do as much. They are like billions. So I forgot the right figure. Amazon had like $20 billion of R&D investment, so huge scale. But we still need to, in our industry, right balance between too little, which has no impact, or too much that we are not able to put, it goes and it's not efficient or is wasted. And that's probably the key dilemma for industry right now, is how do you look at R&D and innovation as an asset and not as an expense? And that's the struggle many businesses have. With bets like 5G, using data, AI, it surfaces the capability, but in an ongoing way, it needs the engagement of the academia and the industry to come together to understand the potential of some of these use cases for it to be used in the corporate world. So that's, I did keep to my time, I guess. And thank you for listening to me.